Right guys, we're back. I'm still on the November 2017 paper 6, got cut off in the middle there, so we have ended up with 2 parts. But carrying on from question 16, we're looking at a parallelogram. So first thing to remember about parallelograms is that these two sides are the same length and that these two sides are the same length. Okay, and then we've got BD is equal to A and AD is equal to B. They're already put on there. F is the midpoint of BC, so that's halfway along. G is the midpoint of DC, again halfway along. This one's a little bit trickier. AE is equal to 3 lots of EB. So if this distance here is 3 lots of this distance, then you've got 4 sections altogether. So this top section is 1/4 of the way along the line. The other section is 3/4 of the way along. First thing we want to do is a simplified expression in terms of A and B for the vector A to B. So that means we want to start at A and finish at B. Can't describe the direct route, so I'm going to go from A to D and then from D to B. So if I go with the arrow, it's positive, against the arrow it's negative, so it's B minus A. Don't forget to underline your vectors. But that is first question already done. If we look at E to B, so a little bit trickier, we've just worked out A to B, so we've worked out as though there's an arrow going that direction. If I want E to B, I just want 1/4 of the line from A to B. So all I want is 1/4 of what I've just worked out. That's what we've just worked out. So I want 1/4 of that, which could be written as 1/4 like that. Or as we might need it later on, we're going to expand the brackets. That's the same as writing 1/4 times B is 1/4 B. 1/4 times A is 1/4 A. Okay, either one of those would get you the mark in this case. Right, show that E to F is equal to this. So E to F means that I want to go from E to B first and then from B to F. And remember, because this is a parallelogram, B to C is exactly the same as A to D. So if I want to go B to F, I just want halfway along this line. So halfway along B is obviously 1/2 of B. So I want to do the answer we've just got. So that's 1/4 B minus 1/4 A. And I want to add on 1/2 of B. So 1/4 plus 1/2 gives me 3/4 of B minus 1/4 of A. And you can see, to show what they've got, all they've done is to make this nice whole numbers in here. We've factorised out 1/4. So if I take 1/4 out of this, I'm left with the multiple of 3. So I've got 1/4 of 3B minus, and if I divide this by 1/4, I've just got 1A. So I've got exactly what they asked for in the question. Right, this is where it gets a little bit trickier. Prove that E to F and A to G are parallel. So we want to prove that the line from E to F and the line from A to G are parallel. Now, if they're parallel, remember these are essentially the same vectors, just one of them will be a multiple of the other. Now, we've already worked out E to F, we've just done that in part B. So we basically want to work out A to G. Now, A to G is all the way along B, plus, and then halfway from D to C. Again, because this is a parallelogram, D to C is the same as A to B. So you want B plus 1/2 of the line from A to B. So what we want is B plus 1/2 of A to B, which we worked out earlier is B minus A. So I've got B plus 1/2 of B minus 1/2 of A. I've got 1B plus 1/2 of B is 3/2B minus 1/2 of A. Now, because we're trying to prove that this is something similar to this one, what I'm going to do is I'm going to factorise 1/2 out so that we're working with nice whole numbers again. So if I divide this by 1/2, I've just got 3B. If I divide this by 1/2, I've just got 1A. So you can see I've got exactly the same vector. I've just got a different multiple in front, which means I can say that E to F and A to G, that A to G, because it's 1/2, is obviously twice as much as E to F. So A to G is 2 lots of E to F, therefore they are parallel. Okay, as long as one is just a multiple of the other, they're nice and parallel. Okay, so on to question 17. We've got the diagram shows a circle with a centre 0, 0. Write down the equation of the circle. Now remember, equation of a circle is always in the format x squared plus y squared equals r squared. So x squared plus y squared will always stay the same. That's signalling that it's a circle with a centre 0, 0. We just need to know our radius. The radius is the measurement from the centre to the outside, and you can see they all pass through 10, which means the radius is 10. So 10 squared is 100. My equation is x squared plus y squared equals 100, or equals 10 squared, whichever way you want to write that. Okay, point P has the coordinate 8 minus 6, so 8 minus 6 is roughly there. Okay, show that the P lies on the line. So all you're going to do is substitute 8 and minus 6 into this equation. So instead of x, I'm going to write 8. Instead of y, I'm going to get minus 6. 8 squared is 64. Minus 6 squared is 36. So as silly as this sounds, I'm going to write 100 equals 100. Therefore, P lies on the circle. Okay, because the left-hand side is equal to the right-hand side. Right, find the equation of the tangent to the circle at the point P. Now remember, a tangent to a circle, a tangent will meet a radius at 90 degrees. So it's a line which is perpendicular to the radius. So first of all, since I know this coordinate here is 8 minus 6, and I know that coordinate there is 0, 0, I can find the gradient of this line. Once I've got the gradient of this line, we can flip it and change the sign to get our perpendicular gradient. And then I've got a gradient and a point to find my equation of that line. So first things first, we want the gradient of the radius. Okay, so the radius, remember gradient is changing y over changing x. So we had our two coordinates as 0, 0 and 8 minus 6. So changing y is minus 6 minus 0. Changing x is 8 minus 0. Make sure that both times you started from the same bracket each time. So I've got minus 6 over 8. Now for the sake of making our life a little bit easier, I'm going to simplify this fraction. I get minus 3/4. Now if that's the gradient of the radius, remember when you come to find the gradient of the tangent, that's a perpendicular line. So you want to flip your gradient and change the sign. So instead of being negative, mine's now going to be positive. That there is getting you 2 marks so far. We want to find the equation of the tangent, so we're using this gradient and we're using the coordinate it passes through, which is point P, and we're going to follow the equation of a line. Now remember, you can do this either way, y equals mx plus c, which is absolutely fine, there's nothing wrong with it. I just feel it's a little bit more complicated than if you use y minus y1 equals m brackets x minus x1. The reason for that is you just substitute your numbers in and tidy this up, and that is it, it's done. Okay, y equals mx plus c takes a little bit more messing about at the end. So I've got y minus minus 6 equals 4/3 of x minus 8. So again, I don't want to deal with fractions. So the first thing I'm going to do is actually put these two minuses to make a plus, but I'm then going to multiply by 3. So I get 3y. We know this is a positive 6, so it's now going to become plus 18. And I've still got 4 outside the brackets. All we're doing at this point is just tidying it up. So if I expand the brackets, I get 4x minus 32. Then what we're going to do is subtract 4x from both sides. So I've got 3y minus 4x add 18 equals minus 32. And we're going to add 32. I get 3y minus 4x add 50 equals 0. There you go. I've got my equation of my tangent. Okay, last question, a little bit more unusual in this one. They've given you areas already shaded in. They want you to find the inequality that defines each region. Now this one should be the nice easy one. Now they want the inequality that shows region A. So we are trying to give the equation of the shaded region. Okay, I know sometimes we shade the region we don't want. In this case, we want to give the equation for the region that is shaded. So first of all, this is a straight line that goes through 2 on the y-axis. So the straight line itself is y equals 2. You can see that they've shaded the region where y is less than 2, and because it's a solid line, they are also including 2. Sorry about this. There you go, printer stopped changing, which means region A is actually represented by y is less than or equal to 2, because we do want the region that is shaded with A. So just be very careful of the way these are worded. Sometimes you shade the region you don't want, sometimes you shade the region you want. Region B, we want an inequality that defines region B. So this one is a little bit trickier, because first of all, you're going to have to work out your equation of your straight line. So this takes a few steps to get there. All you want to do to begin with is we're going to find the gradient of this line. So gradient is that we're just going to draw in a triangle. We've got one right, we've got 1, 2 down. So because it's down, it's -2. So the gradient of this line is change in y over change in x. So I get a gradient of -2. Because I can't use the y-intercept because I don't know what it is, what we're going to do is pick a coordinate on the line. So I'm going to pick this point here, which is 7, 4. So I'm going to use the coordinate 7, 4. And what we're going to do is use that information to get the equation of our line. So I've got y minus 4 equals -2 lots of x minus 7. So if I expand our brackets, we get -2x, add 14, and then if I add 4 to both sides, I get y equals -2x, add 18. And then all we want to decide is that region that's shaded less than or equal to y, or greater than or equal to y. So you can do that by just picking a point. So if we pick a point that is clearly below our line, I'm going to pick 0, 0. Okay, if I plug 0, 0 into our equation, I get 0 is equal to 0 plus 18, which means 0 equals 18. Do we want that to be that 0 is less than or 0 is greater than? So we want above, so it's greater than. So our equation is y is greater than or equal to -2x, add 18. Okay, normally, as I said, we shade the region that you don't want. In this case, just be very careful because we are shading the region that we do want. It's a little bit trickier, but you end up, we wanted the region that was greater than or equal to -2x plus 18. The next one, shade the region on the grid given by the inequality y is greater than or equal to 6. So again, you want to shade the region where y is greater than or equal to 6. So greater than or equal to means that you need a solid line going through 6 on the y-axis. So there's my line. We want to shade the region where y is greater than or equal to 6. So we're shading above. Just be very, very careful with the wording on any sort of inequality graph. And then we've got, and I'll bring that sheet back in a minute, a fourth shaded region given by the inequality y is greater than or equal to kx plus 2 is added to the grid. The unshaded region now has the area 23 centimetres squared. Find the value of k. So if we think about that, we know first of all from this equation that this is in the form y equals mx plus c, which means the plus 2 is my y-intercept. So I know first of all that my straight line is going to cross through 2 on the y-axis. So if I think about it, I've got a straight line passing through 2. It could go through there. I know it has to have a gradient. Okay, it could go all the way through, and what you could end up with is in each of these cases you've got a trapezium all the way to a triangle. So if we just try the triangle, that's nice and easy to check. Base of my triangle is 1, 2, 3, 4, 5, 6, 7, 8. Height is 1, 2, 3, 4. So I do 8 times 4 is 32. Half of 32 is 16. So I know it's not a triangle, so that can't be my line. So what we're going to do is we're going to try and find the area of a trapezium. So what we've got, if I try and keep these on the screen, is we know we've ended up with a trapezium where I know the base of my trapezium from my diagram goes from 0 to 8, so I've got a base of 8. I know that every time the height of our trapezium is going to be 4. That direction is going to be 4. What we're trying to work out is that length there, so we're going to call it x, and we know that altogether it gives us an area of 23. So if I get rid of that piece of paper, so what I've got is area of a trapezium. Remember, that is A plus B, so that's add together the two parallel sides, times by the distance between, and half it has to give us 23. So first thing we're going to do is if I times by 2, I get x plus 8 times 4 equals 46. What we're then going to do is if I just expand the brackets, I get 4x plus 32 equals 46. If I subtract 32, I get 4x equals 14. And then if I divide by 4, I get x equals 3.5. So that means I need this distance along the top here to be 3.5. So again, we're going to go back to our graph. Okay, looking at our graph, what I've got is if this is 3.5, I've got 1, 2, 3, 3.5. So I've actually got that line there. Okay, that would give me an area here of 23.